So, when you see a bee, buzzing from flower to flower, what do you really picture is going on in its head? For a lot of us, it's this image of a tiny, fuzzy robot, right? Just driven by instinct, a little cog in the giant machine of the hive. And honestly, that's a view that's been around for a very long time. For more than a century, this whole idea was really championed by the famous French entomologist Jean-Henri Fabre. He saw insects as these beautiful, intricate, but ultimately mindless little machines. Reflex machines, that's what he called them. Yeah, sure, they did complex things, but he saw it all as just inflexible, pre-programmed behavior. But you have to wonder, is that the whole story? Are they really just tiny, organic robots? Or or is there a rich, complex, and maybe surprisingly intelligent mind whirring away inside that tiny little head? Well, that's what we're going to get into. We're going to bust some of the biggest myths about the mind of a bee. We'll dive into their totally alien sensory world, check out their incredible cognitive powers, their surprising individuality, and then we'll tackle the biggest question of all. Could it be actually be conscious? Okay, first things first. Let's get this straight. A bee's reality is profoundly different from ours. I mean, to really understand a bee, you have to try and imagine what it's like to be a bee. And let me tell you, their world is a sensory wonderland. Their vision alone is just alien. While we see a world in red, green, and blue, bees are actually red blind. To a bee, a beautiful red poppy might just look like a black hole. But and this is the cool part, they see a color that we can't even perceive, ultraviolet. And UV light reveals all these hidden patterns on flowers, almost like landing strips that are completely invisible to us. And that's not all. They can see patterns of polarized light in the sky, which they use as a kind of celestial compass to find their way home, even on cloudy days. Look at this. This is their unique color palette. You know how we see purple as a mix of red and blue? Well, bees can see bee purple, which is a combination of ultraviolet and green light. It's a color that we literally cannot even begin to imagine. And their senses go way, way beyond vision. Bees can feel the subtle electric fields that flowers give off. Get this, they can taste with their feet to check out a flower the second they land. Inside the pitch-black hive, they talk to each other by feeling vibrations through the honeycomb with their legs. And their antennae, they're like a Swiss army knife. They can smell, taste, feel, and even hear by detecting tiny movements in the air. Now, if you have a sensory world that rich, it kind of stands to reason that a bee's brain is doing a lot more than just running simple programs. And you'd be right. Bees have some serious cognitive firepower that just completely shatters that whole reflex machine myth. The most famous example, of course, is the waggle dance. This is not just some quirky little wiggle. It is one of the most sophisticated forms of communication in the entire animal kingdom. It's a symbolic language for sharing abstract information about the world outside. So here's how it works. In the total darkness of the hive, a bee does this dance on the vertical honeycomb. The angle of her waggle run, compared to straight up, tells the other bees which direction to fly in relation to the sun. And then the length of that waggle tells them exactly how far to go. It is literally like giving out GPS coordinates through choreography. And this language is what allows for these incredible feats of navigation. Bees aren't just following some simple compass. No, they are creating detailed mental maps of their surroundings. They memorize landmarks, trees, hills, you name it, to navigate really complex landscapes over miles. They do this using what scientists call a time-compensated sun compass. Basically, they have an internal clock that lets them track the sun's movement across the sky and adjust their navigation on the fly. They know what time it is. And scientists proved this with this amazing experiment where they basically gave bees jet lag by anesthetizing them for 6 hours. When the bees woke up, their internal clocks were totally off, they misjudged the sun's position, and they flew in the complete wrong direction. This proves they're not just reacting to the sun, they are calculating its path. Okay, so we've got a creature with this complex sensory world and some pretty advanced cognitive skills. But the next myth we have to bust is the idea that they're all the same. A hive is not a collection of identical drones. It's a society of individuals. And these differences, well, they start with the physical. Just look at this. Bigger bumblebees don't just have bigger bodies, they have bigger eyes with larger facets. This gives them higher resolution vision. It's like having more pixels in your camera. They can spot smaller flowers from farther away than their smaller sisters can. And those physical differences are really just the beginning. Research is now showing variations in what you could almost call personality. Seriously, check this out. Some bees are bold explorers, always on the hunt for new flower patches. Others, they're more conservative, sticking to what they know. Some are innovators, figuring out clever tricks like nectar robbing, biting holes in flowers to get the nectar, a skill that others just never learn. You even have different work ethics. Some are buzzing from dawn till dusk, while others, seem to prefer just the morning shift. The hive isn't a monolith. It actually thrives on this incredible diversity of individuals. So, all of this leads us to the deepest and maybe the most controversial question. If bees can learn and remember and navigate and have their own individual tendencies, could they also have an inner world? Could they have subjective experiences like emotions or even pain? Now, the classic argument against this actually came from Karl von Frisch himself, the Nobel laureate who figured out the waggle dance. He described this experiment where he cut the abdomen off a feeding bee and he watched it just continue to drink, apparently oblivious as the sugar water poured out its back. For him, that was it, definitive proof that bees don't feel pain. But modern science is telling a much more nuanced story. A key sign of real pain isn't just a reflex, it's the ability to change or modulate that response, and bees do this. When they're defending the hive, an alarm pheromone not only makes them aggressive, but it also acts like a painkiller, turning them into these fearless warriors who just ignore injuries. Bees that survive a simulated spider attack show long-term changes in behavior. They'll avoid dangerous places, they'll act more cautiously. It's something very similar to trauma. This is so much more than a simple reflex. It's a complex response to a harmful experience. And what about positive feelings? This is where it gets even more intriguing. Some plants actually lace their nectar with psychoactive drugs, like caffeine and nicotine, and bees, well, they can get addicted. They'll return to these flowers again and again, even when there's better nectar somewhere else. So why would they do that? It seems plausible that these substances are, for bees, exactly what they are for us. They're mood-altering. So here's where we're left. We have a creature that lives in this vibrant sensory world that's totally invisible to us, that communicates with a symbolic language, that navigates with a mental map, and that shows signs of individuality, trauma, and maybe even pleasure. It's far from a simple machine. The mind of a bee is a place of profound complexity. And that leaves us with one final crucial question. If they possess even a tiny glimmer of this inner world, how does that change the way we see them? And what does it say about our responsibility to protect them?